Welcome to today's lead code problem. Today we're going to be doing a 5 to 8 random pick with a weight. So you're given a zero indexed array of positive integers w, where wi represents the weight of the ith index. And you want to implement a function pick index, which randomly picks an index in the range from 0 to w's length minus 1 and returns it. The probability of picking the index I is wi divided by sum to w. For example, if we have 1 and 3, probability of picking 0 is 25% and the probability of picking 3 is 75%. Okay, that makes sense. To give a couple of examples here, which is good to look over as well. We instantiate a new solution with 1 and 3, and the odds of picking 1 are 3 over 4, odds of picking 0 are 1 over 4, and okay, yeah, this makes sense. Okay, and we have a couple of constraints here. Okay, so one way which I'm thinking of solving this is having something called a prefix sum. So effectively what we can have is we can think of this as sort of like a timeline, right? So we have basically a timeline over here. We start this. We have a timeline over here, and we want, for example, for this one, 1 and 3, we want the it to choose 3 with the probability of 75% and 1 with the probability of 1%, or like was like 25%. So another way you can think of it is if you have like a ball here, and you have a ball here and it's thrown, you want a 1 in 4 chance of it being thrown to index 0 and 3 in 4 chance of it being thrown to index 1. So we have this, and where prefix sums comes into play is that you can have effectively a prefix sum where you keep track of what it is at the given time. So for example, for this one, the prefix sum is 1, and the prefix sum of the second index is 4. Oh, I guess I gotta explain what the context behind a prefix sum is. So a prefix sum is pretty much for like a given index and the element in that index. It's the sum of that element with all the elements previous to it. So that's that's how we're going to find out what the prefix sum is. And if you notice in this timeline here, we have like a 1, and then we have like a 4. Or yeah, we have like a 0. Sorry, our 4 is over here, and then our 1 is going to be over here, and then the 0 is going to be over here. You'll notice that in between these posts, or like prefix sums, so to speak, like there's the range which is equal to the weighting of it, right? So like let's say like if you created like a random pointer or something that's like shot at random, that has a 1 in 4 chance of landing at 0 and a 3 in 4 chance of landing at 1. So like a random value in here. And that's kind of the logic that we're going to use to be implementing this as we go along. Once we do find once we do generate a random pivot, let's say like a random pivot here, we can utilize a binary search in order to figure out where specifically it lies in the prefix sums array, and then we can like have that as our final value, which we can do a probability for. So if that sounds like a good solution, I can go ahead and begin implementing it now. So we're first going to start off with initializing our prefix sums. Self.prefix sums equal to this, and then we have self dot we'll initialize like cur is equal to 0, and then for every single value in the weight, you want to do self.prefix sums dot append the weight, or the total, the cur, and you want to do cur plus equals the value. So that's all we need to do to initialize our prefix sums. At the end of this, we'll have a self.total, which is going to be equal to the total value of all of the elements summed up in the array. So we can have total is equal to cur. Next thing we're going to want to do is, in this one, we want to pick a random value like we were talking about earlier. So we do random, or we'll say like target. Our target value is going to be random times the self.total, because that's going to be basically just throwing a number and putting it anywhere in between 0 and the length of the total value. From here, what we want to do is we want to do while we want to initialize some variables, L and R is equal to 0, and the length of the length of the prefix sums minus 1. So that's going to be our indexes, and we're going to do while left is less than the right. We can check to see the mid. What is the mid? We want it to be the exact middle as part of our binary search divided by 2. And then we want to check to see if the target is, okay, so if the self.prefix sums mid, if it's greater than the target, or if it's less than the target, right? What do we want it to do? We want to move we want to negate, we want to check to see everything to the right. So we want to do L. Yeah, we want to do L is equal to M mid plus 1. Otherwise, we want to do R equal to M minus 1. Or like M, I think, yeah, just M. And then at the very end, what we can do is we can return the left value over here. So just to walk through this again, kind of do like a dry run. Let's say like we have like the 1 and the 3 value over here. What's going to happen is it's going to create the prefix sums 1 and 4, and then it's going to generate this here in it. Next, what we're going to do is we're going to choose like a random value between 1 and the total. So let's say like it goes like randomly here, right? It'll choose like 3. So from here, what's going to happen is it's going to check to see, it's going to do like a binary search. While left is less than the right, you want to figure out what the mid of it is. So the mid of the left plus the right pointer, this is going to be 2, right? Because it's going to be 2 over here. And is 2 less than or greater than the value that we have here? Well, it's less than. So we know that obviously if it's less than, we can negate everything to the left of it and search only for the right for our like, wait, sorry. Yeah. So if our prefix sums mid is less than the target, then we want to negate everything and we want to move on to the right. And then eventually it'll keep doing the binary search over again. It'll move over to 3 and then it'll return that as our final result. That's what we want to return as our index. We can go ahead and begin running this. Oh, we need to do self.prefix sums over here. Yeah. Accepted and submit. Okay, that's great. The time complexity, I'll go over it over here. Time complexity of this one is O of n, where n is the number of elements in the weights. Space complexity is going to be O of n as well, because we're going to be storing like a prefix sum for every single element in the weight array. For the pick index, the time complexity of this one is going to be log n, because you're utilizing a binary search to look through the timeline and basically figure out what the final value is. And for the space complexity of this one, it's going to be O of 1. Yeah, it should be O of 1 because they're not actually allocating anything to the memory as we're going along with this. So yeah, thank you guys for watching.